Let's review a little bit what we did last time. We have 2 years involved, year 1 and 2, keeping it simple. We have 3 goods: bread, bike, dentist. And we calculated nominal GDP in year 1 by taking the quantity of bread, valuing it at the price of bread. In year 1, bikes, 20, valued at $50 a piece. Dentist, 5 fillings at $100 a piece. Multiply these two, add the multiplication of these two, multiply those two, add them all up, and we got nominal GDP. The value of all final goods and services produced in year 1, 1,520. And we did the same thing for year 2 and got 1,670. Then we calculated real GDP. Real GDP is current output valued at base year prices. See, the thing is, with nominal GDP, it went from 1,520 to 1,670. It's gone up. We think that's good when GDP rises, but with nominal GDP, we have no idea why it went up. It can go up because prices went up. It can go up because quantity went up. Well, if it's because quantity went up, that's good. We like that. More production. If it went up merely because prices went up, well, that's just inflation. That we don't like that. So with real GDP, we freeze prices at their base year, and so the only thing that changes from year to year is the output. So we remove the effects of price changes, and so when we calculate, we arbitrarily picked year 1 as the base year. It's just we choose it, flip a coin, whatever, but we have to select a base year. And so we go through, we value the bread at the base year price, which, year 1 is the base year. So there's no change in the base year. So real GDP is equal to nominal GDP in the base year. For year 2, we value these 3 units of bread produced in year 2 at the base year price. So it's 3 times 10. The bikes, 18 produced in year 2, but we value it at the base year price. Dental services, valued at the base year price. So it's 3 times 10 plus 18 times 50 plus 7 times 100 gives us 1,630. And as we can see, now we know something. Real GDP went from 1,520 to 1,630. The only difference between those two numbers is quantity. The prices are the base year, so output did indeed go up. We call that economic growth. Now, we usually don't see these numbers are really big. This is in millions and billions, okay? So we usually don't hear GDP figures thrown around as their actual numbers. What we do hear reported is the rate of change in GDP. Okay, so we want to calculate the rate of economic growth. And that's just going to be the percent change between this number and this number. So let's do that. I'll move that over here. Well, all we really need right now are those 2 columns. Okay, well, first let's review percent change. Okay, this is a formula. We'll use this from time to time. You may have learned this one in 5th grade. Okay, but it may have been a while. So let's play with it. Percent change, in its most general form, is simply x2 minus x1 divided by x1 times 100. Okay, here's an example. Let's say that, I don't know, something goes from 10 to 11. Okay, let's say a price change. Prices go from $10 to $11. At what rate did prices change? Well, x2, well, it's x1. Okay, x1 would be where we started. That's why we call it x1. So we started out at 10, so let's say that's x1, and ended up at 11. So it went from x1 to x2, 10 to 11. Well, let's plug it in. So that would be 11 minus 10. That's the absolute change. I mean, it changed by 1. Prices went up by 1, 11 minus 10. But we want to know that change as a proportion of where we started. Well, we started at 10. So the change as a proportion of where we started, so that equals 1 over 10. And what's 1/10? Well, we usually divide that through 0.10. There it is. Except we do one more thing. See, this is percent change. Well, this is a decimal. That's a decimal. So what we do, one more step, to convert it from a decimal to a percent, we multiply by 100. So what's 0.10 times 100 equals 10. So the percent change is 10%. So that's it. We're going to see that a few times. So percent change, again, in its most general form, is just x2 minus x1 divided by x1. And then we multiply it by 100 to convert that to a percent. Now, I warn you about just moving the decimal over 2 places. Because in your calculator, using a calculator, it's just showing two places after the decimal. And there could be numbers hiding out there. In fact, we're going to see that in a minute. Let's say the real answer is 0.9887, something like that. But in your calculator, it's just showing 0.98. Well, no. Well, I should have just waited until we got to... You know what? Let's wait till we get there, okay? Let's just do that. Never mind. I'll show you what I mean later. Okay, let me get rid of all this. In fact, I should stop the recording while I do this. That's one advantage. But too late. Okay, so what was the rate of economic growth? Well, let me... Economic growth. Well, excuse me. Let's take the percent change, 1520 to 1630. Well, x2 minus x1 divided by x1 times 100. Well, we started out at 1520 and we ended up at 1630. Okay, so that would be 1630 minus 1520. That's a proportion of where we started, 1520. And then we're going to multiply that by 100 when we are done. That gives us 110 divided by 1520. And let's plop that in our calculator. 110 divided by 1520 equals 0.07. Okay. Now, before you just, okay, now we multiply by 100 to get to convert it to a percentage. Don't just move the decimal over 2 places and call it 7%, because there are numbers hiding in there. Your calculator rounds it to 2 places, and that's what you see on your display, unless you set your calculator to show more than 2 places. But I would just actually do the times 100 to see what number is hiding in there. It's not 0.07, it's actually 7.24. So the rate of economic growth is 7.24%. Real GDP grew by 7.24%. And when did that happen? Well, that actually happened over the course of year 2, 7.24. Well, so we'll put it there. Remember, year 1 GDP is at the end of year 1, and year 2 GDP is at the end of year 2. So that growth took place during year 2. So during year 2, we had economic growth of 7.24%, which in real life, that would be an economy on fire. That's a huge growth rate. We'll talk more about what's typical later on, but usually 3% is considered very strong growth. Potential GDP, we call it. Long-term sustainable economic growth is right around 3%. So this would be one heck of a boom. Okay. We aren't just interested in the rate of economic growth. That's a very important number. But we're also interested in inflation. So we've held prices constant at the base year to calculate economic growth, to calculate real GDP, and then the percent change between real GDP from year to year gives us our economic growth rate. But we also want to know what's going on with prices. And to do that, we're going to calculate something called the GDP deflator. The GDP deflator. Okay. The name, the word deflator is unfortunate. It really is better known as, or a better word would be index. GDP price index is what it really is. So what it is you take nominal GDP and we divide it by real GDP. So in year 1, nominal GDP is 1520, real GDP is 1520, and we get 1. And what we also, in here, we multiply that by 100 to convert it to a percentage. Okay, so we times that by 100. So it's nominal GDP divided by real GDP times 100. And that gives us our GDP deflator of year 1 of 100. The interpretation of that, what that is saying is that in year 1, prices are 100% of what they were in the base year. Well, year 1 is the base year. So, of course, they're 100% of what they were in the base year. But that's what that means. And so, in the base year, the deflator will always be 100 because nominal GDP and real GDP are the same in the base year. You're dividing a number by itself. It's always 1 times 100 is 100. So there we go. Okay, how about in Year 2. Well, we've got nominal GDP of 1520, 1520, and real GDP in year 2 of 1630. Okay, so I've erased all that stuff's over here. There we go. Whoops. Year 1, year 2. Okay, let's don't get mixed up here. So we're dividing nominal by real. Okay. 1520 divided by 1630. And that gives us, well, let's get out the old calculator. Well, no wonder my numbers aren't working. Boy, that's what I get for getting up early to do this. Should have done this yesterday, right, when I was fully awake. Okay, let's forget what I just did. It's not 1520. Year 2 is 1670. So yeah, see, I was just testing you. See, that's what I do. I was just testing you to see if you're paying attention. 1670 is nominal GDP in year 2, divided by 1630. Okay, here we go. 1670 divided by 1630. And we get 1.02. Again, we multiply by 100 to convert to a percentage. So we just hit times 100. And we get 102.45. There's the GDP deflator for year 2. 102.45. What that means is that in year 2, prices are 102.45% of what they were in the base year. So prices have gone up. In the base year, they're 100%. Now they're 102%. Now again, this is we're with the GDP deflator, we're doing just the opposite of what we're doing with when we calculated the real GDP, we were holding prices constant at the base year. Now we're holding quantity constant and letting prices change, essentially. So let's take a look. Nominal GDP, what is that? Well, that is current prices times current output, right? Real GDP is base year prices times current output. So when we divide nominal GDP by real GDP, notice that this is the same, output's the same in our number. This is what's changing. The prices are changing. So basically, we've got a ratio of current prices to base year prices weighted by the amount of output. So with the GDP deflator, we're holding output constant and letting prices change. So we know what happens to prices. With real GDP, we're holding prices constant and letting output change so we know what happened to output. Okay, well, where are we? Let's see. Whoops, I didn't want to do that. How many columns we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we're 11th column. We've only got 12 more columns of numbers to go, so we're getting there. Okay, just kidding. We've got one more thing to calculate. And just as with real GDP from year to year, you know, we go from one year to the next. What we see is it reported as a growth rate. The same with prices. We want to see that as a growth. That's a percentage change. And the percentage change in prices, well, think of it this way. Something that costs $100 in the base year now costs $102.45. That's a perfectly good way to think of it. So what is the rate of change in the prices? Well, it's just the percent change in between these two numbers. So we that's x2 and that's x1 in our calculation. We started at 100. We ended up at 102. So that would be 102.45 divided by, minus 100 divided by 100. So that's x2 minus x1 divided by x1. And that gives us 2.45 divided by 100 equals 0.0245. And then we times that by 100 to get 2.45%. And what do we call that number? In economics, that number has a name. And we call that inflation. So the inflation rate is 2.45%. Okay, that's it. And again, because this is actually taking place during year 2, it's from the end of year 1, which is when we know what year 1 GDP is, and the end of year 2 when we know what the year 2 GDP is. So this is actually taking place throughout year 2. So in year 2, we had dynamic economic growth of 7.24%, and we had an inflation rate of 2.45%. Okay, that's it for pretty much for the number crunching here in this chapter.